Lesson 60. Projectile motion. Object shot out horizontally. Any object traveling through the air that has no other force acting on it other than gravity is a projectile. With our experience with throwing or kicking or shooting things, we know that if an object is sent out horizontally, it moves outwards. And as it moves, it begins to drop until eventually it hits the ground. For a horizontal projectile like this cannonball, we will ignore the cause of the motion. We'll focus on the resultant projectile path. The object will travel in two planes in two directions. The x-plane when it moves to the right, and in the y-plane as it moves downwards. Obviously, the object is moving, so the initial velocity cannot be 0 meters per second. However, if we look at the velocity as x and y components, we will find that one of them is 0. Now, to explain this, it is important to remember Newton's first law, also known as the law of inertia. And it states that an object at rest will stay at rest, and an object in motion will stay in motion unless there is an unbalanced force acting on it, where a force is a push or a pull. Let's revisit our cannon. It must have a horizontal velocity in order for the object to move forwards. We denote the horizontal velocity as v subscript x. Now, if there is no force acting on the cannonball, it will continue traveling in a straight line, as per Newton's suggestion. In fact, if it had no horizontal velocity component, it would simply be an example of an object in freefall, falling due to the unequal force of gravity acting on the cannonball. Now, since we know the cannonball does not travel in a straight outward line, based on Newton's first law, there must be an unequal force acting on it. Now, one unequal force may be air resistance, but in grade 11, we ignore it because of its complex effects on projectiles. We term this as being ideal conditions. Without air resistance, there is no force acting on the cannonball in the horizontal plane or in the x-axis. The unequal force we are looking at in grade 11 is called gravity. Gravity is acting in the vertical plane, which pulls the ball downwards, which is why the ball eventually hits the ground. When a cannonball is shot horizontally, it has some magnitude of horizontal velocity. And because gravity is a force that only acts in the vertical plane, and because we are ignoring air resistance, the horizontal velocity v sub x of the cannonball will be a constant. It won't change. However, gravity does act on the object in the vertical or the y-plane. So as the cannonball travels outwards, it may drop as it travels, but the horizontal velocity remains a constant, and as a result, the ball displaces the same amount in each set interval of time in the horizontal plane. Under ideal conditions, the horizontal velocity component does not change. It's a constant. When we shoot a projectile straight out, we get a horizontal velocity, but it has 0 vertical velocity, denoted as v subscript y. But we know that the unequal force of gravity will act on the cannonball immediately. And it is a constant near or on the surface of Earth. We measure it to be negative 9.8 meters per second squared. So even if the horizontal velocity does not change, the vertical velocity does. When we combine the fact that the projectile does not change velocity in the x-plane, but does in the y-plane, we see that the object's displacement in the vertical gets bigger and bigger for each set moment of time. This is based on the force of gravity being 9.8 meters per second squared downwards. Vertical velocity does change. The fact that the horizontal velocity does not change and the vertical does at negative 9.8 meters per second squared results in an interesting phenomenon seen in this video. The left ball is dropped while the right one is projected horizontally. Since only the vertical velocities change, they both hit the ground at the same time. This video shows the same thing, but against a grid pattern so that it's obvious that they accelerate at the same rate downwards, regardless of their initial horizontal velocity. Both the green and the blue ball hit the ground at the same time, regardless of their initial horizontal velocities. For both, they had initial vertical velocities of 0 meters per second. To summarize horizontal projectiles, their horizontal velocities do not change. We will ignore air resistance. We call that ideal conditions. This means that the initial velocity in x will equal the final velocity in x. The vertical velocity does change though, and it changes at a rate of g, which is equal to negative 9.8 meters per second squared. The initial velocity in the y-plane will be 0 meters per second, and the final velocity in y will be of greater magnitude depending on the height of the drop. Please watch Lesson 60 where we solve a problem involving horizontal projectiles.